access to ours.
Great.
Our director in one case.
Okay, that'll be fantastic. Thank you very much, Ron. Appreciate all the work you're doing there. Okay, so ladies and gentlemen, okay, so the first thing I'm going to put into place is a mechanism which is going to intervene upon certain individuals in this model, okay? The way in which we're going to do this is we're going to go take a look at a person's transmission of infection, and we're going to take some of those parameters that have erstwhile lived up here in Maine, and we're going to move them to an individual level. We're going to have them at an individual level. And this will allow us to vary them at an individual level. And the one I'm going to focus on, ladies and gentlemen, will be the contact rate and the duration of infectiousness. The idea being we might be able to, through certain innovations, allow for quicker care seeking, and therefore they'll come in for care sooner. Or we may be able to lower people's contact rate through appropriate messaging or through efforts that would lower risk behavior. Okay? So while these parameters are still things we'd like to set within Maine as kind of the default contact rate, default duration of infectiousness, now we're going to be able to have some individual variability. We could easily draw them for distributions for individuals, have them vary across the population. But in this case, the main way in which they'll vary across the population is by dint of an intervention. So rather than calling this contact rate, I'm going to call it something else. I'm going to call it default contact rate or baseline contact rate or something like that. And same thing with duration of infectiousness. Okay, default duration of infectiousness. That'll be sort of the baseline. And then we'll adjust it from there. Now, notice I switched those things deliberately without changing the things that refer to them. Because now we're going to take these and we're going to copy both of them. Probably should have copied them before I renamed them. We're going to copy them to person. So now we're going to have similar parameters at the person level so that these can vary by person. Now, this thing was just, okay. So what I'll do for the copy is, from Maine, I will go select them like this, and I will do copy. One way to do it is edit copy, or you could right click and say copy, or on many of your machines maybe Control C or Command C. Okay, and now I'm going to go to person. Now any logic is a little bit, it's a little bit of a pain sometimes when you copy things in because it's not obvious. So sometimes I like to kind of look over here to see if the thing has been added properly. So I'm going to paste in, and okay, it actually put them in a not terrible position. So I'm going to copy these here. And I'm going to grab both of them. I did that by pressing Shift and clicking to grab both. And I'm going to use the arrow keys to kind of march them up. Okay? Okay. Next, I'm going to change their names back to contact rate, and duration of infectiousness. But these times, these will be individual level ones. Okay? Are we okay with that? And now, guess on which ones this completing latency will depend. Well, it's no longer going to be this recovery will depend. It's not going to be main dot duration of infectiousness. It'll be this dot duration of infectiousness, my duration of infectiousness for this person. Same thing with contact rate. Instead of using contact rate as delineated by main, I'll use my own contact rate, this dot contact rate. Okay? Are we okay with that? Okay, so I'm in person, and what I did here was I went to main, and I renamed these to be default duration and default contact rate. Then I selected them, and I copied them. And then I went down to person, and I pasted them in. Because I'm creating personal versions of these, so they can differ by person. So some people have higher contact rates, some people have lower contact rates. Some people higher durations of infectiousness, some people lower. Duration of infections might reflect implicitly care-seeking behavior. Okay. Now, and then for this recovery transition, I had it refer not to main anymore, duration of infectiousness, but to this dot duration of infectiousness. My duration of infectiousness, which may differ from the default one, because I may be the subject of an intervention, which has changed that. Similarly, this one here, this transition, this should be called the contact transition, incidentally. It's referring to my contact rate, not just the global one, but my particular characteristics, which might vary, right? We know from...
When you're saying this and my, you're referring to the lowest, the same level. If you wanted to put that in city, you would do, like if you main dot, you would do city dot.
City dot, yeah.
And so this means that there's
They're
no hierarchical.
It's just in, it's because it's in person, this refers to the current person. So remember, a given person, say, is in this state at a given time, and this dot contact rate, so if we're considering that particular person, this dot contact rate is the contact rate of that particular person.
Yeah, I'm just trying to generalize that you only use this. Like you would use this in the city to mean this city if it's at the same level.
Precisely.
Okay.
That's exactly the issue. That's exactly the issue. This, in a city, it refers to the city, the current city. So you're dealing with a city which has a certain population, certain prevalence of infection. This, if I'm writing something,
same level.
If I'm writing something in the city here, if I were writing some code in the city, if I had an event that was going off in the city, this would refer to the current city. That event's going off in some city, it's a fire or whatever, that's occurring in some city. So the event, when that event occurs, this will refer to the city where that event has occurred. And similarly, if this were in Maine, then it's going to refer to Maine. Yeah. So remember, there's particular cities, and things happen to particular cities. There's particular people. Things happen to particular people. And so like this contact or this recovering, that's occurring to a specific person. The fact a particular person is in the infectious state.
Could you use person instead of this?
No.
And if you're in city, could you use city instead of this?
No.
Okay.
No. Unfortunately, you can't. So it used to be, not long ago in any logic, you couldn't even say here, city. What you would, in fact, like if you said here, see I refer to city, what you used to have to say is, what is it, get city. That would be my city. And that's the city associated with me, in which I'm embedded. AnyLogic added this in version 7, so you can easily refer to the thing I'm in. And so this happens to be my city, and it just automatically lets you get that information. Okay? Okay. So, ladies and gentlemen, let's build this model, because we've changed a couple things here. But we haven't finished the thought. What haven't we done yet? Well, we haven't actually set the values to use for the contact rate and duration of infectiousness for person yet. Really, we should do that in the population. And actually, it's copying the default values. In city, if we go to the population here, and we go to the population, it does use the default values here. But I don't want it to use the default. Okay, fine. It should use the one in Maine as the there's a contact rate, a default contact rate in Maine. That's the one I want it to use for the default, okay? So for the city, the default value for people in the city within that city should be given by Maine.contact rate. Contact rate. That isn't the way I'd love to do it, but that's fine. Main dot duration of infectiousness. Okay, default. Thank you. Default contact rate. Okay. Okay. Default contact rate. Okay. I should do a recurrent event. What am I doing? Recurrent events analysis of my errors in this, and I think I'd find they default. What am I doing? They vary in a pronounced way by time of day. Okay, default duration of infectiousness. Okay, great, excellent. There we go. So in short, the contact rate for people in this city will be by default the one in Maine. But now we're going to have it vary by intervention. Okay? That's what's going to happen. Great. Great, ladies and gentlemen. Okay. So, are we ready for our first intervention? Okay. First intervention is going to be very, very crude. Okay? Here we go. So we're going to have a alternative assumption in which we lower the contact rate throughout the whole population. Okay? So here we go. We're gonna take the baseline. Let's copy the baseline. Copy baseline. By the way, baseline was the one I named, which has this 3-year on average time till migration. It's the baseline. So copy it. And now let's paste it. And ladies and gentlemen, this will be called lowered contact rate. So we're assuming that we can somehow persuade people throughout the population to lower their contact rate, maybe through an advisory. Mind you, I showed you a model earlier today. We actually have implementation science aspects where it would actually simulate how does this intervention play out. We actually simulate the dynamics of the intervention. And that's a rich area, and that implementation science thing was giving a nod to that. And I think it's a huge area of growth for agent-based models because we can simulate the mechanisms of the intervention. It's readily doable. And if there's interest tomorrow, I'd be glad to help show how we might do more of that. But for now, we're going to assume in a classic form that we have lowered the default contact rate from its default value, which was I think the default contact rate was 1, and we will assume that we've lowered it by 10%. Okay? So we're going to lower it to 0.9 per day. Okay? This is a lowered contact rate. Great. And, of course, let's see, by so doing, we will have some impact on this dynamics. Now, what we don't have in this model yet, which I would add if we had another hour, which we don't, would be outcomes indicators. Okay? But we don't have that in place now, and we don't have time to put it into place. But next, ladies and gentlemen, I'm going to put in place a targeted campaign which will lower contact rates. Okay? And this is going to be a little bit advanced, but it's going to be extremely powerful. How we're going to do this. Okay. We're going to have a campaign which changes contact rates for the population based on a person's network status, and then soon based on a person's history. Okay? Okay, so ladies and gentlemen, I would like you to go and add to main two things. Okay? The first thing that I'd like you to add to main will be these are going to be two parameters, and one of the parameters is basically going to describe whether or not a person is eligible for a given intervention, and the second is going to describe whether or not they are what intervention to perform on them. The idea here is that rather than changing the whole model to implement an intervention, running it and then changing it back, we want to be able to specify on a per experiment basis, a per scenario basis, what intervention we want to apply and on whom to apply it. And then we have some scenarios which are applying intervention A to different subgroups of a population successfully, and we have other scenarios applying intervention B to different subsets, and then sometimes A and B together to different subsets. We can mix and match these interventions, okay? That's the idea. Are you okay with that? Okay, I don't hear any objections. Okay, so let's go for it. Okay, let's go to palette. We're going to add in a parameter. This parameter, ladies and gentlemen, is going to be unlike any parameter you've ever dealt with. Okay? Okay, this parameter is going to be called is eligible for intervention. Okay? This parameter, it's going to be a function. It's not going to just be a value. It's not going to be true or false. It's going to be something we give it a person, and it's going to tell us whether or not it's eligible. They're eligible. Whether or not they're qualified for the intervention. Okay? Ladies and gentlemen, we're going to go down to the bottom here, and we are going to set this to a dynamic parameter. Okay? Down in the advanced area, dynamic parameter. Dynamic. Do you see that? Down at the, so what did I do? I dragged in a parameter, called it is eligible for intervention. Then I scrolled down to the bottom where it said dynamic parameter. Okay? This is going to serve as a function. It's going to be a rule. And we're going to give it a person, and it's going to say, are you eligible for the intervention? Okay? Now, ladies and gentlemen, you'll notice, having done that, there are now an area called arguments. Now, arguments are basically the information this needs to do its job. It's going to be the person we give it. So we want to give it a thing called candidate person, and it's going to be of type, well, what type do you think this will be? What's called candidate person. It will be, do you think it'll be a city? It'll be a person, indeed. We're going to give it a person, and it's going to tell us, are they eligible? Okay? And this rule is going to capture eligibility criteria. Great. Okay. Great. Ladies and gentlemen, the default value of this parameter will be false. Someone's not eligible. But each intervention can specify, each scenario can specify a different rule. For some scenarios might use ones, it will allow someone who has enough connections to be eligible. Another one, if a person's been infected enough times previously, they'll be eligible. Another one, if they have no history of ever being infected, they're eligible. Whatever. Okay? Oh, the type is not double, it's Boolean. Thank you. Thank you. Man, you folks are good. Okay. Okay. Great. Okay. Are you ready for this? Okay. Next, let's drag in perform intervention for a person. We're going to parameterize this model by how we intervene on someone. So different scenarios will have different interventions. Some may lower contact rate. Some may lower duration of infectiousness. Some may lower the latency of infection or what have you. So this will be perform intervention for person. Now, this parameter, let's drag it all the way down to the bottom. This will be what's called an action parameter. This parameter will perform a certain action, okay? It'll perform a certain action on a person. And the arguments for this parameter will be called person on whom to intervene. And it will be of type person with a capital P. Okay? Person. And the default action will be blank. We don't do anything. Okay? Those are the two mechanisms that we will use in this model to perform an intervention, a targeted intervention, potentially. Are we ready for this? Okay.
What's the type?
The targeting will be based on criteria of who's eligible. We're going to be able to specify that. Okay. Ladies and gentlemen, let us now go put in an event that will implement this. And this will be called perform intervention. Okay? And we will set this perform intervention. We could set it to occur once at time 0, but I'm going to set it instead to be the trigger type, the mode to be cyclic, and the trigger type to be timeout. What that means, it's going to occur every so many days. And I'll set it to occur once every month. Once a month, we will undertake this intervention. Okay? Perform intervention. This, let me go over that. Trigger type timeout. I didn't change that. Just occurring after a certain fixed time. Once a month. It's cyclic with a cycle of 1 month. Are we okay with that? The action here, ladies and gentlemen, the action is going to sweep over the population and apply this intervention and check if they're eligible. If so, apply the intervention. Okay. Okay. So we're going to do for each person in the population. That's how we write it. We're going to loop through each person in the population. Whatever rule the modeler told us for the given experiment, if that rule indicates this person is eligible, and I'm going to write is eligible for intervention, if the person is eligible for the intervention. Remember, for different experiments, we'll use different eligibility criteria, different rules. If they're eligible, we will perform the intervention on that person. See that? No. Okay. Oh, sorry. There's a wayward D. Okay. 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 Now it's yeah, it's messier because it's a hierarchical model. Okay, fine. Okay, fine. Let's just move this. The easiest way to do it, the easiest way to do this is to move this event into city. Okay? So I'm going to take this event and we're going to put it, we're going to cut it, and we're going to paste it into the city. Okay, perform intervention. That's the easiest way to do it. It's a little bit more overhead computationally. And now, instead of if is eligible, it'll be if main dot is eligible, and main dot perform intervention. And this will be a happy camper. Okay, there we are. I'll put this up on the big screen. So what did I do? I just copied perform intervention to city. It had been in main. Now I copied it to city. And now it will loop through for the city, its population, and apply. It'll ask, is this person eligible in the population? So it's looping through each of the people in its own population. And if so, it'll perform the intervention on them.
You don't need the curly brackets?
Okay, that's a good question. Curly brackets would be quite curly brackets would be great to have, but you don't require them, and that's because there's only one statement in it. It's called. There's only one thing being done inside of it. So curly brackets are particularly used when you have multiple things going on within that this for loop. But if you only have one thing going on in there, they're not required. Okay, it can be good practice to include them, and that would allow you to lower some risks. If you had code afterwards, it'd be less likely that you'd think the code was in the loop, but it turns out it's not. But you don't need them. So if you want to put curlies, they're good. But if you don't want to put curly brackets, that's fine too. Okay? In this case. Notice I do indent. I always indent to show the logical structure. This is logically inside the if statement, and the if statement is logically inside the for loop. That is, the for loop iterates over executing the if, and inside of the if is the thing that it considers whether or not to execute. Are we okay with that?
So you moved the event from the main to the city?
Yeah. Moved it from main to city. Because I'm having each city do it, so I have access to the population. I could have done it in main, but I would have had to first loop over cities and then over the people within the city. Or I could have told the city, perform the intervention on you. It just seemed easier to do this way. And then maybe you could have some cities that perform the intervention more frequently than others, which would be quite interesting. If you had some cities which were very vigilant and others were not, what would the implication be for system-wide transmission? Okay, Winchell or Alan? Okay. Okay, who would like this to be shown longer, though? Are we ready to run this thing?
Well, I have a question.
Yeah.
What is an intervention? You just said that perform intervention.
Yes.
Is eligible for
Yes.
intervention.
Yeah.
What is the intervention
We're,
itself?
we're going to now set that, okay? So this provides us the requisite flexibility to encode a huge number of different interventions. And that's just the point. We don't have to modify the model anymore to change the intervention. The intervention can be specified for each experiment independently, okay? So we're going to do that. So let's make sure that this that the system still works, that we don't have a problem here. And so this intervention, applying a null intervention, there's no intervention right now. It's eligible for intervention, just says false. Everyone is not eligible. Okay, let's set up an intervention now, okay? So we are going to set up a intervention here, which is going to be lowered contact rate and duration of infectiousness. So this will be lowering both contact rate and duration of infectiousness across all the population, okay? And we could do this with parameters alone, but I want to show you how it's done here. So is eligible for intervention. It will be everyone in the population. So what does this need to do? We want to intervene upon everyone in the population. So what do we need to return for this? Is eligible. Who's eligible? Who is eligible, ladies and gentlemen, if everyone in the population is being done? Well, everyone's eligible, so it's true. What is the intervention here? It will be person on whom to intervene dot contact rate equals, and I'll say times equals 0.9. Okay, we're going to lower their contact rate by 10%, or we'll just say equals 0.9. Let's keep it simple. Equals 0.9, and we will lower as well their duration of infectiousness, okay? And we will lower that from its default value, which I think was it 7 days? Do people remember? Was it, I think it was duration of infection is 7 days. We will lower it to 7 times, so 0.9 times 7, okay? We'll lower it by 10% as well, okay? So here we've intervened upon everyone in the population, lowering their contact rate by 10%, lowering their duration of infection by 10% as well. Okay?
The baseline contact rate, or this is the person? Yeah, doing.
So this is setting their particular contact rate. This is the person on whom to intervene. So everyone is eligible, and for those people who are eligible, so it's going to be everyone here, their particular contact rate will be set to 0.9. Their particular contact rate will be set to 0.9 times 7. Okay? Now I'm going to run this, and now we've lowered contact rates, right? And we've lowered durations of infectiousness. We're still going to have, it looks like there's a little bit of something going on. Someone recovered down there, but I don't see them. Now they've become susceptible again. Okay, I'm running it again. I still don't have an outbreak. I still don't have an outbreak here. Okay, no, here's someone red. Okay. Are you getting outbreaks?
Yeah.
Okay, maybe I'm just getting unlucky here. Okay. Okay, this person, you're getting a little bit of something going on. Okay. Okay, there's an error here. Okay, so next, ladies and gentlemen, I want to restrict for this model this intervention to only occur in people who have more than 10 network connections. Okay? We want to restrict it to people who have more than 10 network connections.
Nate, can I see that message, the last message?
This one here?
Yes.
Sure, I'll put it up on the big screen. So, ladies and gentlemen, we have the prospect that each experiment will allow us to specify a different intervention and a different eligibility criteria for that intervention. So, I'd like now, ladies and gentlemen, I'd like you to set it so that we're going to have another experiment. We're going to copy this one we just created, and we're going to paste it in again, and we're going to have the same basic thing, but for high connection, or say for hubs, okay, for people who are hubs. Now we're going to come back to this issue of who's a hub, and we'll put in some statistics for that, but we're going to say duration, we're going to lower these two things for hubs. So now, instead of our contact rate being, we're going to apply it for everyone, we're going to apply it only for people who are candidates who match a certain criteria. And our criteria will be here, candidate person dot get connections number is greater than, I'm going to say greater than 15. Greater than 15. Where did this thing candidate person come from? Where did this thing person on whom to intervene come from? Does anyone remember? Where did this come from? That's right. So when we defined these things in main, when we defined this, remember it took what I called an argument. It took some information it needed to do its job, candidate person. And perform intervention for person took person on whom to intervene. And for those things, this within city, ladies and gentlemen, within city, perform intervention is going through each person in the population, and it's asking, is that person eligible? And if so, perform the intervention on them. And so if we're looking, ladies and gentlemen, at this one, at this criteria, the candidate person is the person passed whose eligibility is being queried about, whose eligibility is being inquired about, is this person candidate person. And we're asking, do they have a large number of connections? Similarly, if we are intervening on a person, we are setting the contact rate for that person on whom to intervene to be here 0.9. We're setting the duration of infectiousness for that person to be this thing here. So now we are intervening only upon a subset of the people, okay? We're intervening upon a small subset of the people. Now, I'm tempted to show visually that this person is intervened upon, just so we can make it really obvious. Are you okay with that? Okay, let's do that. Let's go to person, and let's try to figure out a way to make it really obvious that they've been intervened upon. What are we going to do? Let's make their skin glow. What do you think? Make it a certain change color, the skin?
Flash, you mean?
Well, I mean, if sorry, that sounds kind of scary. There's a line color around the shaped body. There's a color associated with the edge of the line. And then there's a color inside of the line. And so I'd like to make the line color something obvious. Or we can make them larger. What do you think we should do? Make them bigger? Make them bigger. Okay, fine. So we'll make them bigger. So let's put associated with the person a variable that will be called is intervened upon, or has been intervened upon. So I went to person, and from the palette, I dragged in a variable. What do you think type this variable will be? Is it a double?
Boolean.
It's a Boolean. It's a true or false. Are they intervened upon? Its initial value will be false. No one's intervened upon first. And it's only when they're intervened upon we'll set this variable. We'll set it. What do you think? Okay? Okay. Okay, ladies and gentlemen, we could do this in several ways, but that's one way to do it. And now let's go to shape body for them, and let's set the scale of shape body. The scale, which right now is 0.5, we'll set it to be 1 if they're intervened upon. So they'll grow in size, they'll grow in stature. Okay? So scale for them will be dependent on has been, so I went to shape body for the person, and I'm going to set the scale to be, if they have been intervened upon, it's 1.0, otherwise it's 0.5. Just the same thing for this. Let me put that up there on the big screen. If they have been intervened upon, their scale is 1.0, otherwise it's 0.5. Okay? Are you okay with that? So we introduced a parameter, has been intervened upon, and now we're making it visually obvious that they're intervened upon by setting their shape body down here in shape body, scale X, scale Y to be 1.0, and if they are intervened upon, they'll be larger. They'll be size 1, otherwise 0.5. Can we do that, ladies and gentlemen? Okay, ladies and gentlemen, I appreciate your patience. This is very good. We're in a good situation here. Okay, so the final thing we have to do is we have to go, when we intervene upon someone, we need to set that. Oh, of course, we just do it here. We don't have to do it in each rule. Perform intervention. Now we need the curly braces, Dina. Now we need the curly braces inside of here. If they are eligible for the intervention, we're going to perform it on them, and then what else do we have to do? We have to mark them as having been intervened upon. Perform intervention dot has been, what am I doing? What am I doing? Person dot has been intervened upon equals true. Just like that. Let me put this up on the big screen. All I did is I just added these curly braces and I added this line here where I said, you've been intervened upon, you've been intervened upon. Each time someone is eligible, we perform the intervention on them, and then we mark that we have performed the intervention. And now, it's a thing of beauty. It's a thing of great beauty, ladies and gentlemen. Now, for eligibility criteria, we can return false if they've already been intervened upon. Right? We can make it them only eligible for new intervention if they've never been intervened upon before. What do you think?
Sorry, I just had a question about when we did the candidate person get connections.
Yeah.
I had an error. It's telling me that it's not a.
Get connections number?
Yeah.
Okay, so
You could just pop over to where you wrote it, please.
Sure. So that would be in for the hubs, this thing here.
Okay, all right, thank you. I know what I did.
Okay, great. Remember, autocomplete is your friend.
I thought I did.
Yep.
Obviously not.
Okay, ladies and gentlemen. But there also is a get connections, and maybe that's because there's also one. So autocomplete won't be. Sorry. You want to see that? Yeah. Greater than 15.
Yeah, perfect.
Okay. So ladies and gentlemen, I'm going to run this one first. Lowered contact rate, lowered duration of infectiousness. And what I'd see here is that everyone's going to be larger. They're all large. Why is that?
Because
they're all intervened upon. Everyone is intervened upon. Let's do this one for hubs. Let's see if anyone's intervened upon. I actually don't know. A lot are. Oh man, there are also ones. Maybe we need a stricter criteria. Maybe, and this gets to the point. I was going to put in a histogram of how many people have how many connections. Let's try that. 45. Okay, now a subset of people are larger. Okay, it's a subset of people. Okay. Now you'll notice here these criteria are right now deterministic, right? Ladies and gentlemen, the criteria right now are quite deterministic. We could flip a coin here to determine if someone's eligible. We could say, people with 10% probability would be eligible, or 1% of the population each time we roll out the intervention. In short, we could make this probabilistic based on whether they're eligible or not. And then we have successive rollouts of the intervention reaching different subsets of the population. We might also, within this eligibility criteria, say someone's not eligible if they've ever intervened upon before. Okay? If there's interest in this, I could elaborate tomorrow. and take this example significantly further. Another thing we'd want to do for this model, which we will do tomorrow morning, we're going to run this model for a Monte Carlo ensemble. What that means is we'll run it again and again and again with different random numbers so that we can see how variable are the results or how consistent are the results in terms of some of the health outcomes involved. And we'll put in place some output statistics, particularly in the form of histograms, okay? Which will be basically displaying for us the number of connections people have in the population, and which could better inform this criteria, get connections number. Finally, I'll just put in place one final intervention here where we'll copy this one we already had, copy it, and we will put, actually, I think I'll leave this one for tomorrow because it will depend on, we'll accumulate a statistic, how many times a person's been infected. And we'll have a record of that, and we will govern the intervention by the count of times they've been infected, okay? And so we'll intervene upon people preferentially who have been infected a larger number of times. So this gives some sense of interventions. The idea is that each scenario here can encode a rule about who is eligible for intervention and what intervention to perform. The way in which that intervention is performed in this simple model is by changing parameter values. In general, as we saw earlier today, you could have actually quite a bit more articulated intervention structure where we simulate the rollout of the intervention, we simulate its successive effect on behavior due to that rollout in a more indirect fashion. We simulate the pathways of intervention impacting behavior. Here, we've done it in a classic way, quite common in infectious disease modeling or dynamic modeling, where we directly change parameter values. Okay, that's one way to perform interventions. What's nice about how doing it this way is you can have targeted interventions or more broad interventions, ones that depend on dynamic criteria, like the number of times someone's been infected, ones that depend on or the number of connections one has. And through this, you can have quite rich different scenarios that investigate interventions. So tomorrow we'll come back to this model. If there's if there's interest, we can elaborate it with additional richer intervention types, and we will examine its impact. We'll examine how the model results vary by according to stochastics for different runs of the model. Okay, so that will be for tomorrow, and we're meeting in 716B. We will try to be there by 8 o'clock, and we would welcome people anytime after that. Okay, so I think we'll stop for today. We've lost a lot of the people. But I'm happy to answer any questions. I will now go post this model, okay? This model will be version 6, okay?
Does that mean we gotta turn this room back around for?
Yes.
Right.
Is that the requirement, like there's going to be room there?
I don't know.
Unfortunately, Alan, sorry. I appreciate the TA's good.
I can't remember how